We're now going to begin Chapter 6, which is about continuous probability distributions. So in this video, we're actually going to talk about the uniform distribution. And then in the following videos for the chapter, we'll talk about what's known as the standard normal distribution. So for continuous distribution, there are infinitely many x values for the distribution. So we won't be able to give a table like we could in Chapter 5. So we'll give a graph that will represent the probability distribution. So there are two important properties about a graph of a continuous distribution. The first one is that the area under the graph is equal to 1, because all of the probability values must add up to 1, and that there's a correspondence between the area and the probability. So you can actually find probabilities by finding areas under the curve. So the first one we're going to talk about, like I said in this video, is the uniform distribution. So a continuous random variable has a uniform distribution if its values are evenly spread over the range of possibilities, and the graph of the uniform distribution has a rectangular shape. Another way of saying this is that any time or something happening at any time has the same probability. All the x values have the same probability. So we're going to see a rectangle, and so our base will be along the x-axis and our height will be along the y-axis. And just remember so this is the base and this is the height. So the area of a rectangle, you may have heard it as length times width. That's the same as base times height. So here's our first example. So it says an alarm will go off sometime in the next 5 minutes. Given below is the graph of this uniform probability distribution. So we know that the alarm is going to go off in the next 5 minutes, and we're saying that it has an equal chance at going off at any time. So we know this is a valid probability distribution because the total area, so if we find the area, remember we just said base times height. So our base here is 5 units long times our height is 0.2. And if you take 5 times 0.2, you do get 1. So since the area is 1, we know it's a valid probability distribution. So the next part says use the area under the graph for the interval to find the following probabilities. So the probability that the alarm goes off within the first 2 minutes. So if we look at the first 2 minutes, that would be this area of that rectangle I just shaded in blue. So this area, well, we would take the base of this blue rectangle we now made, which is 2, and the height is 0.2. So we would take 2 times 0.2, so we'd get 0.4. So there'd be a 40% chance that the alarm would go off in the first 2 minutes. Now we want to look at the probability that the alarm goes off between 2 minutes and 5 minutes. So I'm going to erase what we've had to make this next part. So from 2 to 5, we're going to draw that part of the rectangle and shade it in. We want this area that's shaded in. So from 2 to 5, this is a width of 3, right? Which you can kind of count, or if you think of doing 5 minus 2, that gives you 3. So this 5 minus 2. And the height here is still 0.2. So we would take 3 times 0.2. So we'd get 0.6. So there's a 60% chance that the alarm would go off between minutes 2 and 5. And then the last part is the probability that the alarm goes off at exactly 3 minutes. So drawing this, exactly 3 minutes would be kind of that instant And that rectangle has no width at the instant just 3. So this is 0. So whenever you have at exactly one time in a continuous probability distribution, the probability is 0. And that's what this next sentence says. For a probability distribution of continuous data, the probability of exactly one value is 0. Okay, we're going to do 2 more examples with the uniform distribution. So number 2 says, assume that packages are sent from the post office during one particular hour had weights that were uniformly distributed between 1.8 pounds and 11.8 pounds. So if we draw the base, and we go from 1.8 to 11.8. Now we need to figure out what the height is going to be. Now we know the rectangle must, the area of the rectangle must add up, multiply to be 1. So remember, this is our base, and we know our base times the height must equal 1. So our base here, if we're going from from 1.8 to 11.8, that's a width of 10, and we can tell that by doing 11.8 minus 1.8 is equal to 10. So our base is 10. So we're going to have 10 times the height is equal to 1. Well, now we can solve for the height by dividing both sides by 10. So the height must be 1/10, or 0.1. So our height is here at 0.1. So now that we've set up our probability distribution, we can actually solve what it's asking. So it says find the probability that a random package has a weight between 2.2 and 5.7 pounds. So I'm going to draw this in another color. So, and I'm not being super accurate with where I put these, but so if we want to be between 2.2 and 5.7, so we'd want the area of that rectangle. So we're going to find the base times the height of that red rectangle. So remember, to find the base, you can do the higher number, 5.7, minus the 2.2. So that's going to give us 5.5. So our area, which is the same as our probability, is going to be 5.5 times 0.1. Sorry, I made a mistake here. I apologize. So 5.7 minus 2.2 is 3.5. So we'd have 3.5 times 0.1, which would give us 0.35. So the probability that it's between 2.2 and 5.7 pounds would be 0.35. Okay, so the next one says, the length of our statistics class sessions are uniformly distributed between 72 and 82 minutes. Find the probability that a given class session will run more than 78 minutes. So if it's going between 72 and 82 minutes, well, that's a width of 10. So if we do 82 minus 72, we get 10. So our height is going to be 1/10. So the height will always be 1 divided by your base, how wide your base is. So 1/10 is 0.1 again. So this will be up at 0.1. So we want the probability that it will run more than 78 minutes. So that means it could run between 78 and we know it stops at 82. So this is the rectangle we want. So the probability that its x is greater than 78. Well, the width here, if we take 82 minus 78, that'll be our width, and we're going to multiply it by our height, 0.1. So 82 minus 78 is 4. So we're going to have 4 times 0.1. So our probability will be 0.4. So that will be our answer for this question.